So, able, right?
Hi, Krishna. Is it audible to you?
Yes, sir. How about me?
Yeah, it's audible to me. Thank you.
Oh, okay. Yeah.
Right. Krishna, the session is live streamed right now. I think you have an access to share your screen. Could you please just check once and share your screen?
Just give me a minute. I will just, yeah.
All right. Okay.
Yeah. I hope my screen is visible, right?
Just a second. I'm just checking it. All right. Okay. Krishna, one more thing. We have participants on our YouTube channel. So what I request you is, if on your phone, I request you to open our YouTube channel and see the comments there. You can mute the audio, but you can see the comments there because the participants would be attending it from session from there and they will be asking the questions.
Okay.
Yeah. Yeah, just let me know once you have an access to your phone and the YouTube.
So about the YouTube, like, yeah,
Just go to our YouTube channel, and you'll be able to see all the participants. Okay, so it's 6:59. Should be starting the session in a few minutes. All right. Hi, everyone. Very good evening to all of you. Thanks a lot for joining in. The people who have joined on our YouTube channel, thank you very much, because we had a lot of people and we couldn't accommodate everyone on the Zoom. So that's why we're trying to move to YouTube as a platform so that we can have more number of participants. So we have Krishna, who's a senior simulation engineer. So who will be starting the session in a minute or two. Just waiting for about 1,200 people have registered for the program. Just waiting for I know many of them to join in. Give us a minute here. All right, Krishna. So if you're good to start, I think we have about 90 plus participants on our YouTube channel. We should be good to start because participants also can watch the the session later too. I mean, they can back forward the session and watch it later too. So we should be good to start. So yeah, I can see your screen, and I think you can maximize the screen by presenting it. So cool. Let me begin ahead with a quick intro, and then you can take over the session. All right. So very good evening, everyone who have joined here. Thanks a lot for joining in and showing your amazing interest to learn the topic on EV specifically, and also the part of battery calculations as a today's topic. So the very interesting thing that we discussed in the last lecture series was how we can use an Excel to calculate the motor sizing requirements, and where we designed about a lot of detailed information. And today we will be talking about more on the battery side. We will talk about different type of cells that you can use for the battery, and if you use a specific cell, how many number of cells you require in series, or how many number of cells you require in parallel configuration. And in derivation of that, you have to also evaluate the energy density of the battery pack, and volumetric energy density and gravimetric energy densities. A lot of these things you will derive by end of it. You'll also look forward to calculate the weight of the battery pack, volume of the battery pack, a lot of these things, and it will be quite an engaging and interesting session as usual that we deliver from Decibel's lab. So I hand over the session to Mr. Krishna. Krishna, over to you to take out the session and keep it interested and exciting for all the participants. And I think you have also access to your YouTube streaming. I believe you have an access, right, Krishna?
Yeah.
Great.
Yes,
I
sir.
think
Yes, sir.
Perfect. So we have participants from there who will be posting the questions. So in case I request you to just look through your screen, where you'll be able to also, see the queries and address them. We would have a lag of about a minute, not more than a minute, I believe, about 45 seconds sometimes. So yeah, they may ask the question slightly later. So yeah, you could have sessions for discussions in QA to move quickly forward. Thank you very much, everyone, and over to you, Krishna, and to deliver the session, and over to everyone to enjoy the session ahead. Thank you very much. Bye.
Yeah. Thank you, Suraj. Yeah. Now, good evening, people. Okay. Today, we'll start with cell selection and battery pack development, how the things are going to be, how the approach is going to be. It's one of the part I'm going to discuss. In order to select a cell, right, and to build into a battery pack, a lot of procedures are there. Lot of things are to be considered. In that, I'm just considering one part of it for a kind of cell selection, and then how to do it for up to the battery level, up to pack level. Okay. Yeah. With this, I will just start. So here, how I'm going to write whatever the equations and whatever the things I'm going to consider, I will be explaining simultaneously with the theory also. Yeah. So here, I have made some consideration or the requirements for the thing, how to go for the battery design. I have considered for some a range of 150 kilometer. Okay, as per our norms, if you see here, just give me a second. Yeah, if you see here this point, right, I have battery, the full voltage is I have made a limit of 48 volt, and this is the battery pack we have to design for 150 kilometer of range. This is a fixed kind of thing. Okay, and then these are the energy consumed per kilometer from the respective drive cycles. I have you may wondering that how I have got these things right. I'll just explain. Initially, we have done powertrain simulations and everything. At the end, I got energy consumed per kilometer with respect to these MNDC, WLTP tricycle, FTP, and RTMS ruler. Okay, including all the parameters with respect to the vehicle, whatever dynamics related. So I got these values. Okay, and I have made the average of these values. So approximately I will get about the energy consumed per kilometer, and then the total energy of the battery should be designed. Okay, energy consumed per kilometer. So total energy is whatever the energy consumed per kilometer and the range which we have considered. So it will be 5,700 watt hour, 5.7 watt hour. We have to design it for 5,700. Sorry, 5.7 kilowatt hour. Okay. Yeah. So there are some consideration we have to make in the further. So yeah. I'll just move to the next slide. Let me clear all the diagrams. Yeah. These are like we'll include all these equations like before going into the Excel sheet calculations. You will get like what I'm trying to do. So battery current is nothing but like we know like whatever the equations like the derivation, the flow of charge from the combine of two or more cells or from supply from the sources. Like its unit is amp hour. So the particular to calculate battery current, we are using these the particular equation like battery voltage, battery power divided by battery voltage. You will get the battery current. And with respect to battery capacity, yeah, it is like a defined product of the current that is drawn from the battery while battery is able to supply the load uh, until its voltage is dropped to a lower than the certain value of the cell. Like, yeah, to calculate the battery capacity, like we are using the particular equation like battery energy, uh, like to calculate battery capacity equal to battery energy divided by battery voltage. Okay. Yeah. Just try to take down the equations like while we are doing with respect to the Excel sheet calculations, like I will explain like how to consider and everything. Okay. Just give me a minute. So in order we should know like the cells in series and cells in parallel, like how to calculate, yeah, and how to calculate the number of cells in total. Okay. In order to calculate like cells in parallel, like we should know have the battery voltage and the cell voltage, battery voltage divided by the cell voltage. See, like the number of cells, like whenever you connect, I'll just give me a second. So if you just consider cells, okay, the terminals I'm just taking into as a reference. So if you're connecting like from positive to positive or negative to negative, like simultaneously, like you can consider them as cells are connected in parallels. Like if you are trying to connect the cells, like just give me a second. Yeah, plus minus plus minus, like in this way, like positive to negative, like they will be in series. So if you connect the cells in series, right, the voltage is going to be multiplied, and vice versa to the cells which are in parallel. Like if you connect the like cells in parallel, like the capacity or the current is going to be like doubled, okay, or going to increase. Yeah. So I'll just go to the next thing. So try to take down like these specification sheets, self specification sheet. Uh, or just take down the like only particular this one. Yeah. Okay. I'll just try to clear all the names. So or just take down the pick of it. Like we are going to use all this data. So initially, like we'll start with the cell level calculations, like whatever the equations which they are going to come, like we'll discuss, and then we'll move to the Excel sheet. Okay. For the cell level and battery level calculations. So here, in order to calculate the volume of the cell, like the equation, like we know, right? Volume of the cell equal to like area into length. If it's cylindrical, right, the area should be like pi into d square upon 4, this particular thing. Like if the cell is of different type, like pouch or the prismatic, like we are going to calculate like height into width into thickness. I have made some mistake here. It should be width here. Okay. Yeah. Here also it should be width. So yeah, and these are respect to the volume of the cells. Okay, and then the battery cell energy, like cell capacity into cell voltage, uh, to calculate the battery cell energy. Okay, just try to take down all the equations. Just give me a second. Mm,
Yeah, I think Krishna, that has been replaced NS and NP, so you just have to go back and forth.
okay. Yeah. Okay. Just okay. It should.
Number of
Yeah, I
cells
got
in
it.
series is battery voltage by cell voltage. That is right. Yeah, I think you
Yeah,
changed the name
this
to
should be
this
of.
place.
Yeah, yeah,
So that is just the interchange in the naming convention. Yeah. So
yeah.
it's just a naming convention. On the other side, it is correct.
Yeah. This should be parallel. Okay, just consider it as a parallel. It's with respect to the parallel, and this the equation is with respect to series cells in series. Okay. A small interchange has become. Okay. Yeah. So yeah. Okay. I'll just consider that you have taken down the equation. I'll just move to the next part. So like in order to calculate like volumetric energy density and gravimetric energy density of the cell, like first before that, like we'll just get to know like what is volumetric energy density, like how much energy, just give me a second, like if you just consider a cell, right, like how much energy just a system or the cell contains compared to its complete volume. Okay, that we need to calculate. Okay, and if you try to define the gravimetric energy density, like energy, the total amount of the energy which contained in the system or the cell compared to its mass. Yeah, so cell energy divided by like a volume of the cell, and then same with respect to gravimetric energy density, uh, cell energy divided by mass of the cell. Okay. Yeah. So just try to take down the equations. Okay, I'll just move to the next part. Cell current, like in order to calculate like cell current, just try to consider this as the C rate into the cell capacity equal to cell current. Or just try to take down the equations, like I will try to explain along with the Excel sheet. Okay. And the same with respect to the cell power, which will be in the watts. So cell power equal to cell voltage into cell current, E equal to V into I. Cell power. So this is basic Ohm's law. Okay. Yeah. This is like this part will be of like cell level calculation, and this is the battery level calculations. Okay. So to calculate the battery current, the C rate into battery current into battery capacity. Sorry, this is battery capacity. So C rate is multiplied with battery capacity, so you'll get the battery current. Yeah, the same with respect to the battery power, like P equal to V into I. Okay, the battery voltage into battery current. Okay, just try to take down the equations. Just yeah. So these are like pack level calculation related equations to calculate battery pack voltage, battery pack capacity, battery pack energy in watt hour, and battery pack mass and battery pack volume. So just try to take all the equations. Yeah, I'll just try to say like the battery pack voltage like equal to number of cells in series, which we are going to calculate. Okay, and then the cell voltage, whatever the cell voltage we are going to get, right, we are going to multiply with the cells which are in series, then we'll get the battery pack voltage. Sorry, the battery pack. What? Let me check. Okay, just give me time. Just let me check. Yeah, I have made a mistake. Sorry. It should be in watts. Okay. Yeah. I have written correctly. I have made some mistake here. Yeah. Okay. Just move to the next part. So I hope you have taken the equations, right? Yeah. Yeah. So the same with respect to the pack level, like volumetric energy density and pack gravimetric energy density. Like whatever the with respect to cell level we have done, like the same with respect to pack level, and the same with respect to like pack level, pack nominal voltage, pack and battery pack under voltage, and battery pack over voltage. So yeah, like if you have taken all the equations, like I'll just say like what to do next. Just give me a second. Yeah, here in the thing, like we are planned to design for a pack or the battery pack for 150 kilometer of range, considering like the total energy consumed per kilometer is like 38 watt hour per kilometer. So total energy, like we are getting thing 5.7 kilowatt hour. Yeah. So here we'll try to just do small calculation here. We'll first calculate the number of cells like in the series and parallel. Okay, like the first thing, uh, for that, yeah, so that yeah, okay, if you just consider this one, we'll just move to the next part, like calculation of battery pack and cell calculation with respect to the Excel. I'll just try to go to the next part. So we'll initialize the battery related parameters first. Just give me a second. Yeah. So just try to do along with me. Just consider the data. Okay. We have whatever I'm going to type it right here, right? Uh, which are shown in the Excel sheet, in the presentation. Those respect to cell parameters, I'm just considering it here. Okay. Manufacturer. Type cylindrical. Manufacturer Panasonic and type cylindrical. Okay. And then model in CR 1865 1865 no 500 B. Yeah. Length of the cell 0.0653. Diameter of the cell 0.0185, and height of the cell, like so it will be as a 0. Okay. And width for the cylindrical, like it should not have like width, right? Yeah, there is no such thing width for cylindrical, and also with same with for the thickness. So I will explain like why I mentioned here. Okay. Mass of the cell 0.046, and capacity of the cell 3.2. It will be amp hour. Okay. Over voltage 4.2. It will be in the volts. Okay. Sorry, 4.2. Yeah. Under voltage 2.8, and C rate 0.9, .2, This is like peak C rate. I can just say, I just mention it as a peak. Okay. Yeah. So if you are like new to this term, like you can just go and visit our like earlier videos, like you will get the explanation. Okay. Nominal voltage 3.7. Yeah. So I'll just try to give this as a for a border. Yeah. Okay. So I just try to write the equation. Before that, I will assign, like I'll just select this one, cell level calculations, and then battery level calculations. Okay, just keep it as battery level. So, first we'll start with the, I'll just try to assign the thing like what we are going to calculate here. So I'll just assign here. Okay. So I'll just write it here instead of writing it here. I'll just explain. Okay. Here, volume of the cell. And here is the battery level. First, we'll start with the calculation with respect to cell level, and then we'll move to the battery level. Like at the end, we'll discuss like purpose of all these things. Okay. Yeah. Next, cell energy. Cell volumetric energy density. Density. I will just keep it as okay. Let it be. And then cell gravimetric energy density. Density. Cell nominal voltage. Just first assign the like what we are parameters we are going to calculate, and then I will start assigning the equations. Okay. Cell over voltage. Cell nominal voltage. Yeah, cell under voltage. And then cell capacity. Cell current. Like these cell current, like these are like continuously like whatever the cell which the current which you're going to try to give, right? Like we are drawing the current from the cell. Okay. the cell peak current and the cell continuous current. Okay, yeah, cell current peak, like how much like max peak current, how much we can draw from a cell. And this cell refers to like continuously how much current we can draw from the cell. Yeah, like for the static conditions. Okay, cell power, like the same with respect to cell power in the peak. And then cell mass. Okay, so some data like we'll get directly from here, and some we have to calculate here, like complete calculation we have to do. Okay, yeah, parameters, just try to make it highlight so that you can easily get it. So like initially, like we need to calculate like volume of the cell. For to calculate the volume of the cell, like we have considered the cell of cylindrical type. So V equal to A into L, like which we already discussed. V equal to A into L. Sorry, just give me a second. Yeah, V equal to A into L. Like A we know pi d square upon 4. Uh, this refers to the length, so area, and this refers to the length. So I'll just try to assign the equation here. So equal to area, like we don't know the area, so we need to calculate. Pi value is 3.142 is multiplied with d, that is diameter. We know the diameter, right? Yeah. So I'll just try to select this one, and then I need to square it out. So I'll write power comma 2. So if you try to write 3, right, it will just give the cubic answer. Okay, I need like, yeah, I need the square value. So pi d square divided by 4. Yeah, before that I will try to multiply the length. Okay, length of the, just give me a second. Yeah, the length of the cylinder is like 0.0653. Here it is. I just try to say enter. So give me a second. Like, so I need to add a bracket, I think so. No. Maybe, yeah, I'll just try to make it in this way. (3.4) d square, right? Yeah. Multiply to d. Yeah, that's given correct value. maybe I made some mistake with that equation. Okay, yeah. And now we'll calculate the cell energy. I'll just try to clear these things. So cell energy, like we know the equation, nominal voltage is multiplied with cell capacity. So we have the nominal voltage and cell capacity. Okay, I'll just try to assign the equation here, equal to cell capacity multiplied with nominal voltage. Here is the nominal voltage. And just try to say enter. Yeah. And then we'll calculate cell volumetric energy density. So for the volumetric energy density, like we already know that the equation is volumetric energy density, cell energy divided by volume. Okay, I'll just try to assign this equation here. Like at the end, we'll discuss like what we are trying to do. Okay. Just, yeah, cell energy divided by volume. Yeah. And then we'll calculate cell gravimetric energy density. For that, the equation is cell energy divided by mass of the cell, which are given. Okay, like cell energy we already calculated. Here I'll just try to make a small change here with respect to the same. This is, if you consider this a gravimetric, and it will be the mass. Okay, yeah. Cell energy divided by mass. So we'll consider this mass. Okay, say enter. Yeah. Now we'll assign cell nominal voltage, which is given here. Here, 3.7. And cell over voltage is 4.2. Like some equation will be directly assigned. Like we'll do the calculation again in the battery pack level, the whole calculations. So I have mentioned it's 2 times, right? So I need to delete this one. Let me, yeah. Okay. Cell under voltage is 2. Just let me check. 2 point. Where it is? 2.8. Cell capacity. Like we need to. Here it is. Capacity of the cell is 3.2. Cell current, like we need to calculate, like, yeah, for that the equation is yeah, we'll definitely, like, I'll just let me complete this. I will mention the equations. Okay, like units, cell current we need to calculate. capacity into C rate equal to into C rate. This C rate like whatever the cell current like we have calculated, it is for like continuously. This for the peak conditions. Cell current for the peak. Okay. Capacity into peak C rate. Cell power, nominal voltage into cell current. Just give me a second. Nominal voltage into cell current. And here for the cell power for the peak. Okay, the max power which we can draw from the like cell. Peak current. I just try to clear these things. Cell peak current. This one multiplied with cell current. Sorry. Just give me a second. Cell power. Okay. Peak current. Peak cell current into nominal voltage. Peak cell current into nominal voltage. Here is the nominal voltage. Yeah. And the cell mass, like we can directly mention here. So we just try to mention the units here. Meter cube. Cell energy like just give me a second. Okay, it should be voltage into peak current. Yeah, I have mentioned the voltage into peak current, nominal voltage into peak current. Okay. Okay. Yeah. I'll just try to complete this thing. Just give me a second. Yeah. Density like mass per meter cube. Just give me a second. here, like, to calculate the cell power, right? Like nominal voltage into like cell peak current. Like if you taken down the equations, like as I shown in the presentations. Yeah. Volt. Cell capacity, ampere, current in amps. The same thing. Power in watts. Just give me a second. Okay. And cell mass in kg. Okay. It's watts. So, like I have mentioned the things with respect to parameters here only. Yeah. So we'll do the with respect to battery level calculations. Okay. The same thing. I just try to mention. Yeah. Volume of battery. Battery energy. Unit remains same with respect to the things. Metric energy density. Yeah. The watt hour per meter cube. Yes, it's correct. With respect to like volumetric energy density. So here I mentioned, I think so. Just give me a second. Metric cube kg per sol. Just give me a second. Watt hour per meter cube. I just forgot to mention these things. Sorry. Yeah. Here I need to mention, because like it was hidden, right? I just got confused. Watt hour, just give me divided by watt hour divided by mass kg. Yeah. So I'll just try to extend these things. Yeah. Now let me check, like I have mentioned everything, right? Yeah. So we'll continue. With respect to the pack level calculations. So yeah, we'll also mention the units along with it, like not to get confused. Meter is to Q. Battery energy, watt hour divided by meter cube. Volume, yeah, 3. Just let me extend, otherwise I'll get confused. Okay. Next we'll write battery gravimetric energy density. Energy density and battery nominal voltage. Battery over voltage. Just give me a second, guys. Okay. Next, battery under voltage. Next, battery capacity. Battery current. And then battery peak current. I'll just mention it as like as mentioned I for the cell thing. Okay. Like you'll get confused. Okay. Now battery power and battery power for the peak. And cell mass, battery mass. I will just try to assign the units for it, like before going to calculations. Watt hour per kg for the gravimetric energy density. Voltage will be of like in volts. Sorry, just give me a second. Yeah, and the same for the voltage. Under voltage and capacity for battery capacity. It will be in amp hour. Amps for battery current. For the peak current, like unit will be of amps only. Or you can just say A, like you can just type A also, just A. Yeah. Watts. Power will be in the watts. kg. Yeah. So we'll start with the battery level calculations here. We'll just try to assign the equations. So before that, like as I mentioned, so we need like number of cells in series and parallel, like get to know. Okay. For that, we'll just try to do some part of calculation here. As in the previous, like we got like 5400 watt hour, right? So if you try to divide with the battery voltage, like we'll get some cells like, sorry, we'll get battery capacity. So with the battery capacity, from the battery capacity, you can just calculate the number of cells in parallel by dividing it with the cell capacity. Okay. The same with respect to like voltage, like total battery like 5.4 watt hour divided by battery voltage, and then dividing it with the nominal voltage, like we'll get number of cells in series. Okay, we'll just do that. First we'll calculate the things here. So just let me clear. Yeah. Here initially, like I have mentioned, the pack voltage we have limited to 48 volt. If you just consider, if you just try to divide it with 48 volt, like just try to calculate and tell me in the chart. Meanwhile, I also do some calculation. Okay. 5400 divided by 48. We get like 112.15 as amp hour. This is completely of watt hour. Okay, and this is of volt. This is of battery volt, like the limit as per our norms. So if you know the cell, like whatever the selected cell, as per now, we have selected this particular cell, okay, and its specification. We know the capacity of it. So we are going to try to divide with this capacity. Just try to do this calculation. Okay. Anyhow, like I will just try to do it here in the Excel sheet. Let me do that thing. It will be very easy to understand. So before getting into this one, we'll do. Yeah. Sorry, it was 5700 watt hour. Okay. I'll just assign that one. Otherwise, I need to go back to the like presentation. Oh, it's okay. Yeah, I just try to do it here only. The battery voltage, what we have considered here, 48, right? Yeah, as per our limit. Okay, and then the considerations, let me do, like the capacity was 5,700, right? Sorry, the total energy, just let me write 5,700 watt hour. Just I will write here only, it will, yeah, the limit, or like as per our norms. And just let me, yeah, 5,700 H watt hour. And so here we'll write unit. Okay, we, yeah, it will be difficult, like again with respect to the calculation. Okay, so we'll try to get battery capacity here. Just by dividing the total battery energy, like divided by the total battery energy, that is 5,700 divided by the battery voltage. Okay, I just try to select this one, divide it with 48 volt. Yeah, before, like we calculated like earlier, whatever 112 we got, right, that is for 5,400. Okay, here we consider as a 5,700 watt hour. So here on this we have calculated the battery capacity, and then we know that cell capacity, right, 3.2. So we'll write number of cells in parallel okay. Here capacity will be of amp hour. I'll just try to write the unit along with it. Number of cells in parallel. Okay, battery capacity divided by the cell capacity. Okay, yeah, where is cell capacity? Yeah, here. So like we require number of cells in parallel is of 37. And then number of cells in series, you can just call it as NS, and this one is NP. Like total battery voltage divided by cell voltage of that is particularly a nominal cell voltage. Okay. Oh, just let me, yeah. Battery voltage divided by nominal cell voltage. So number of cells in series, like 12.97, like approximately like we can consider as a 13. Yeah. So this is like one part, like if you have considered like 48 volt, like as per our norms. So with respect to like we will calculate here also, and I will explain like why I have done and how to do like further things. Okay. Yeah. Just let me volume of the battery. So before like for the volume of the battery, we require number of cells. Uh, so total number of cells. The equation for the volume of the battery is total number of cells into cell volume. So for that we require total number of cells. Cells. Okay. So we need to multiply like cells in series into cells in parallel. Just give me a second. Someone has stated like, sorry, someone has sent message. Why not 60 volt? I will explain like at the end. Okay. But I just I'll explain like why I consider 48 volt only. Like for the two-wheelers, like as per our norms, like we should consider 48 volt only. Whatever the energy like which I consider energy consumed per kilometer initially, it was like 38, right? Yeah, watt hour per kilometer. So it was for two-wheeler. Okay. Yeah. Just try to clear this diagram. And just number of cells in total number of cells. So total number of cells is 481.41. So yeah, I'll just try to with this I'll just try to calculate the further things. I will also explain like how to select like with different cells like comparing with each other. That will be the last part of the explanation. So just let me complete this back level calculation. Okay. You'll get a clear idea like after the explanation what I'm trying to do. Okay. Yeah. Volume of the battery, like we know the equations, number of cells into cell volume. We know number of cells here and we know the cell volume from here. So I just try to assign the equation for it here. Okay. Total number of cells into volume of the cells. Just say enter. This is the battery volume. I have mentioned the unit here. You can just check it out. And battery energy, number of cells into cell energy. So again, I'll just try to assign the equation here. Total number of cells into multiply cell energy. Cell energy we have calculated here. If you can see here, 11.84. I'll just try to assign that one. Say enter. So I'll just try to explain. Okay. And then battery volumetric energy density, battery pack energy uh, divided by battery volume. Okay. So battery pack energy is this one, like 5,700 watt hour or 5.7 kilowatt hour. Okay. And volume, battery volume. And then battery gravimetric energy density. Okay. The equation is battery energy divided by battery mass. I just try to write the equation. Battery energy, the same thing, divided by battery mass. So for that, like we need to calculate just for the battery mass. First, we'll calculate this battery mass. Okay. The total number of cells into the cell mass. Cell mass multiply total number of cells. Okay. We know the battery mass. So we'll just calculate the battery gravimetric energy density, which is battery energy divided by battery mass. Okay. Yeah. Battery energy divided by battery mass. Okay. Now we need to mention the battery nominal voltage. Okay. Battery nominal voltage, just say it's a 48 volt, like which we have considered. And for the battery over voltage, like for the single cell line, it's of 4.2. So I just try to mention this one over voltage of the individual cell is multiplied with number of cells in series. This is like battery over voltage. Okay. And battery under voltage equal to under voltage of the given cell, like is multiplied with like total number of cells in series. And battery capacity, just give me a second. Okay. Like a lot of people having the doubts. Okay. Yeah. I just continue and like I'll give the solution for all at the end. Okay. Battery capacity. Cell capacity into cells in parallel. Number of cells in parallel. I just select this one. Cell capacity multiplied with number of cells in parallel. Okay. So battery current, right? Battery capacity into C rate of that particular cell. We have calculated the battery capacity here only. So I'll just try to select this one and multiply with C rate of continuous C rate. Okay. And then battery peak current. I'll just try to mention a peak C rate into like multiplied with battery capacity again. So this one, yeah. And battery power, for the battery power, battery nominal voltage into battery current for the like continuous battery power which we can draw from it. Battery nominal voltage, here it is, multiplied with battery current. Okay, just say yes, yeah, which will be in the watts. Okay, and then battery power like of the peak one, yeah, it's battery peak current. Battery peak current is multiplied with battery nominal voltage. Peak current multiplied with battery nominal voltage. Yeah. So these are like, I'll just try to explain. So if you consider, so for particular like 48 volt, and then like we know like for how much initially like we have decided, I'll just try to say like for how much kilometer, like 150 kilometer we have decided for to design with this particular data, right? Okay, we have considered single cell only and its specification, and then for that like we decided as per our norms we have considered 48 volt only, and then with this we got the total energy. From there we calculated the number of cells and series, cells and parallel and cells in series. So if you just try to consider like cell level calculation and battery level calculations, so what if like if you this is one approach like for the calculating for the designed uh, range, that is one part. If you are trying to know like if you want to do the cell selections, like if you have like different cells from the suppliers, like it is of cylindrical, like you may be having of like other pouch cell, prismatic cell, and again in the cylindrical cell like there are other suppliers, Toshiba, Panasonic, and other some Chinese companies. Okay, like lot of suppliers are there. So in that, if you want to do the proper selections using like in the mechanical way, like for considering in terms of volume, energy densities, total space consumption and mass, whatever. Like initially we'll mention out the number of cells in series and total number of cells, like cells in series and parallel. With respect to, we'll just try to calculate and select with respect to the different cells. Like if you have mentioned, I'll just try to show that Excel sheet like which we already built. So this is approach is for like if you are planning to design some with some range. Okay, range with a known fixed voltage, like if you are considering for two-wheeler, like uh, for some conditions like as per norms we have to consider only 48 volt only. Okay, yeah, I just try to show the other sheet also. Yeah, if you consider just neglect this one. Okay, just consider these two data. So if you want to do the proper selection from it, right, like whether you have to choose this one for your pack for your battery pack, or whether you want to choose this cell for your battery pack development, like there's the other approach. So we know like initially we calculated the number of cells in series is 37. I just try to note down those things here. Okay. And number of cells in series is 13. 37 and 13. The total number of cells is 481. Okay, I'll just go to the sheet. You can just see you can just observe these things. I just try to change these values. Number of cells in series are 13. And number of cells in parallel are 37. Yeah. So we got like almost 481 cells in total. So with this thing, like you may go for selecting between the cells based on the energy densities and like volumetric energy densities, capacity, current, if you see. So I have mentioned like datas of 2 cells here. Just try to compare by yourself, like looking at the things. So if you just consider, okay, oh, I have made some mistake here. Okay, let it be. Just try to neglect this one. It's like gravimetric energy density with respect to these 2 cells. Okay, let me show. This is pack level of the particular this data, and this is battery pack level and the cell level of this particular this cell. Yeah.
Hi, Krishna.
Yes, sir.
I think we might have come to almost the closing point of it, I believe, the session.
Yeah.
Right.
I think like I have shown 2 approaches, like for the fixed design, or like if you are planning to know like already knew the things and you are just trying to select in between the cells. Like if you have a lot of suppliers, like if you are planning to select particular cell.
Understood.
Yeah.
Right. Fantastic. Any more points that you would like to showcase to the Excel sheet, Krishna?
No, like it's okay. Yeah.
Right. Fantastic. Cool. So awesome. Then I think we have a very in-depth approach of calculating the components. Guys, I mean, this is a static approach, one way that a lot of parameters and trying to evaluate your pack design and stuff like that. So you would have to go a lot in depth, when you try to go in calculating the battery pack sizing, because there are a lot of parameters that also comes into a picture, maybe in a very dynamic conditions. Maybe, if you consider as in pack, also parameters such as influence of capacity degradation over time, because when you're promising a warranty of a cell, so you would have to ensure that you're ensuring the degradation parameters too. So at sometimes when you say it is 2.5 kilowatt, it's in reality it may be 2.8 kilowatt also, because you would have that compensation factor that over a span of time when the battery pack has degraded, it's still possibly showing you about 2,400 that it is still under the warranty. So because and things like this, and also the selection of a cell has been defined already here by Krishna, that when you have a cell, and how do you approach the pack sizing and things like that, but how do you arrive at that cell selection is also another parameter where you have to understand a lot of things in terms of maybe it's not only the energy from the motor that you draw, it is also from the other auxiliary systems, maybe your HVAC system, maybe your motor cooling energy, battery cooling energy, and maybe about parameters such as regenerative braking energy. So all of these parameters, and maybe the impact of temperature, and possibly influencing many other scenarios, and discharge characteristics, a bandwidth of operating temperatures. A lot of these things will come into a picture when you select a cell And now this part of the course is more about you have a cell, and now how do you pick that cell to build a pack, and what you have in comparisons of the weight, volume, volumetric energy density, and also the weight to power ratios and stuff like that. So if you really want to go a little in depth in making these things, you really have to go for making simulation studies where you can have a dynamic scenarios, where you also can simulate the temperature rise in the cell. You want to ensure that temperature rise to be below a certain specific value, and a lot of these things can be done. This is I would not suggest you if you're a guy who's trying to build a vehicle with this Excel sheet. And this is for a reference calculations for somebody who's just a beginner. And as I was telling in the last of sessions, so we take about 500 to 600 hours of billing to design components, or size the components and optimize the components for two-wheeler, about 1,000 hours for a four-wheeler market. I mean, it's a huge, quite in-depth approach of sizing the components and optimizing them. So in that regards of it, we intended you to do the Excel sheet, because if you follow the whole course in due structure, so I think you guys should be able to build that Excel sheet. I appreciate you that you use the parts of this video to build the Excel sheet than actually getting the Excel sheet. Can we incorporate regenerative braking calculations? See, you need to think about, is it a static system or is it a dynamic system, right? So regenerative braking is a dynamic system, so you need to calculate with respect to drive cycle. So when you have to calculate with respect to drive cycle, so that means you need to be also incorporating all your drive cycle data from the model that you have been built. So including all these things are very complex, using an Excel sheet, and that's why we intended to go for a simulation-based approach using a MATLAB and things like that. So we have courses that you're interested to learn using MATLAB. I think we also have advanced course on regenerative energy modeling, because regenerative energy is not just what you get as a motor. You also need to understand what is your SOC. You need to understand your values of the voltage that you get at region. A lot of these things matters a lot. It's just not like you just calculate a regenerative and then you put it. There are a lot of control strategies to incorporate regenerative braking. Though it is just a fancy word, but it is having a lot of complexities to get implemented in the vehicle level. In the same way, it is not possible to include that in the simple Excel sheet calculations. So you would have to run a lot of simulations. If you're interested, connect to us personally. We have courses where we can help you to get in-depth exposure to a lot of these things. And cooling system, we would look forward to have sessions and cooling system. How shall we incorporate graphical representation for comparison of variety of cells and suppliers? Right, Mohammed, I think it is not there right now. I would try to look forward to have discussions maybe in the upcoming week. We'll see forward if we can create that content and share it across to you guys. Right, so how to decide the C rating? So C rating is a static value. If you know the nominal capacity of the cell, that is what is called as equivalent 1 C rating. So it's just depending upon your cell, like the cell you're selecting, and equivalent of that is your nominal capacity of the cell is basically your C rating. So assessments will be shared tomorrow. It will be available on our account. We'll also add this video. Then you can also be able to watch this video and then complete your assessments. So people who might have not attended today, so we intended them to attend it tomorrow through the recorded sessions. And then you can go through an assessment. It is basically like a simple 10 question quiz with a grading of 80% to it. So yeah, that's it. You just have to take part in it, and then you can get the certificate going ahead. Cool. So just in the interesting point of it, if somebody is interested to learn further, you will, it's a very complex system. I know there is like very primitive content available in YouTube on how exactly to do it, because nobody want to teach you something which is very expensive to do it for a free of cost. There are some people maybe teaching using Simscape, not with the fundamental equations. It's fairly bring blocks and assemble it, but you would not really know to a very in-depth level of how you can do calculations using the equations and stuff like that. So yes, that's I think it from my side and Krishna's side for today's session. It was quite amazing to interact with all of you. I believe you all have enjoyed the session. So please do share your feedbacks on the chat box that you have liked it. Also, let us know, what you would like to expect in the upcoming sessions and upcoming weekends. We will be definitely happy to, share these details to our team and try to come up with some sessions that we can, make it more useful for you, right? So, any other questions from your side? We are still open right now. How to calculate the battery aging effect? Battery aging is a very complex phenomenon. It just not be possible to put through an Excel sheet, Mr. Srinivas. So we will definitely have to go a little deeper in modeling a cell, right? So for that, you need to have a lot of cell data because there are two approaches how you can take, either on a equivalent circuit based approach or on physics based approach. Physics-based approach may not be very easy for you because you need to have a lot of computational power. But yeah, equivalent circuit-based approach is something very easy that you can approach, but you need to have a lot of cell data, and that is a variation in terms of different parameters you need to evaluate. Okay, so it's just not straightforward in doing it. I would look forward that we can comprehensively package something and come back to you with the approach of doing the aging calculations. All right, so motor control calculations, okay, and fantastic. So what about depth of discharge? So again, as I said, DOD depends upon your discharge currents and things like that. So you cannot do it here. You can do it either with a previous Excel sheet. You can integrate the previous Excel sheet for the battery calculations, and you can perform a DOD, because you would have done the motor battery energy consumption, right? So you can go for it. All right. So when is the assessment? All right. I just said just a few minutes back, the assessment is there by tomorrow about evening before 5. We will upload it, and nothing to worry. We will send you an email with the instructions for you. Right. So the motor, I think I'm not very sure. I've gone through the videos on your site. Yeah, you can definitely go for the assessments on the same thing. I think the access was given to all of you to take part in it. Cool. Awesome, guys. Then thanks a lot for everyone who has been participating here on this occasion. So if you are interested to learn about amazing things through MATLAB, so you can definitely jump into some of our platforms, which is lms.decibels lab. So where you'll be able to get into this section. So we have also a master course where you can get a placement by the end of the course. That is about 8 months long program. And we also have a micro specializations. If you're anybody is interested to just begin their journey, still not very serious about making their careers, or you're in second year or third year of engineering, you still have time to enter into a decision of a career, so you can take and begin your journey with these things. Currently, the one we talked about is micro specialization in BV powertrain systems and powertrain sizing. This has a lot of information for you about regenerative braking, SOC estimation, DOD estimation, pack sizing, everything that is required for you to basically understand the sections of powertrain. And if somebody is interested, you can go into this section where we have specifically on EVs. All right. Certification programs and educational internships. You can go to a certification program section, and then you just hop in here. This is the other course as an individual one, apart from micro specialization, which is EV powertrain modeling. Then we have these courses. We are not currently providing these courses to everyone, because somebody need to have an understanding of level 2 to undergo a level 3. So somebody asked me about traction regenerative energy modeling. So we have a very in-depth content. I think it's about 15 plus hours, only to model the motor and a model regenerative energy and put a control system parts into a regenerative energy. It's this is not something which you can just deliver over the Excel sheet. You need to have software. You need to perform simulations and understand component by component. So we have that content available. If somebody is interested, you can also send us an email. So we are always reachable to anyone, on our platform. So you just can go here on our homepage, and you can just write an email to us on any of these, contact details. You can write an email to contact@decibelslab, or you can reach us on any of these contact numbers. All right. So we are here to help you, and if you would like to learn and get yourself into EV very seriously, we have helped to transform many engineers too. So we can also help you in the same way with our knowledge and with our expertise in the areas of EV. So cool then. Thanks a lot, everyone. That's it from my side for today, and from our team. Just last seeing through any comments and questions in the chat box. Okay, I think that's all in terms of the questions. So thank you very much, everyone. Good day to you. We will send you the assessments by tomorrow, and we'll also send you an email on how do you take part in the assessments and complete your certifications is also a part of it. All right, then. Thank you very much, and good day to all of you. Good night. Bye-bye. Take care.